Welcome to Astronomy Daily, your go-to podcast for all things space and astronomy. I'm Anna.
And I'm Avery. We're thrilled to have you join us for another episode, packed with the latest and most exciting news from beyond our planet.
Today, we've got some great stories to share, from groundbreaking satellite launches to potential encounters with interstellar objects, and even a peek into how AI is shaping the future of astronaut health.
So get ready to dive deep into the cosmos with us, right here on Astronomy Daily. Let's get started. Kicking off our news, we have a major stride in global weather and climate monitoring. The European spaceport in Kourou, French Guiana, saw the successful launch of the first in a new series of satellites, the METOP second generation, aboard an Ariane 6 rocket.
That's right, Avery. This isn't just any satellite. It marks a new era for weather and climate monitoring from polar orbit. Liftoff happened on August 13th, and within a few hours, we had confirmation that METOP SGA-1 was alive and well, solar arrays deployed, ready to generate power.
It's fantastic news, especially given the increasingly erratic weather patterns we're seeing. This mission is designed to build on the legacy of the first-generation METOP satellites, but with significantly enhanced capabilities.
Absolutely. A key part of this new satellite's sophisticated instrument package is the Copernicus Sentinel-5 instrument. This is crucial because it's designed to deliver critical data on air pollutants, ozone, and climate-related gases. Simonetta Celli, ESA's Director of Earth Observation Programs, really highlighted the value of these strong partnerships in getting this done.
And Phil Evans, the Director General at EUMETSAT, emphasized the real-world impact. He pointed out that extreme weather has cost Europe hundreds of billions of euros and tens of thousands of lives over the past 40 years. This METOP SGA-1 launch is a significant step towards giving national weather services sharper tools to save lives, protect property, and build resilience against any climate changes.
It certainly is. The METOP SG mission is planned to comprise 3 successive pairs of satellites, operating for at least the next 2 decades. Each pair will have an A-type and a B-type satellite carrying different but complementary instruments to capture a wide range of observations. This first one, METOP SG-A-1, is an A-type and features 6 instruments, including the all-important Sentinel-5 spectrometer.
It's amazing how these satellites will circle Earth from pole to pole, covering the globe approximately every 24 hours. Giving us highly detailed measurements from their relatively low orbital altitude. This capability, combined with Europe's geostationary Meteosat series, really maximizes the effectiveness of data for weather forecasting and climate analysis. It's a comprehensive approach to understanding our planet's atmosphere.
Next up, let's talk about United Launch Alliance. They just fired off their first fully operational Vulcan rocket, marking a significant milestone in space launches.
That's right, Anna. This powerful View launcher successfully boosted 2 military satellites into space, making it the first Space Force-sanctioned flight for the Vulcan. It thundered to life on Tuesday evening at 8:56 p.m. EDT from Pad 41 at the Cape Canaveral Space Force Station.
It sounds like quite the sight, soaring over the Atlantic with almost 3 million pounds of thrust. The 198-foot-tall Vulcan is powered by 2 methane-fueled BE-4 engines and put on a spectacular skylighting show.
But this launch isn't just about the spectacle. It's a major milestone for United Launch Alliance. The Vulcan is strategically replacing their older rocket fleet, specifically the Atlas V, which uses a Russian-built first-stage engine, and their already retired Deltas. This has been a big push to have an all-American launcher.
That makes sense, given the geopolitical climate. So, what were the payloads on this important first Space Force mission?
The mission carried at least 2 satellites, 1 classified spacecraft, and a crucial experimental satellite called Navigation Technology Satellite 3, or NTS-3. This is the Pentagon's first experimental navigation satellite since the GPS precursors were launched in the 1970s.
And what exactly is NTS 3 designed to do?
It's designed to test upgraded atomic clocks and navigation technology that could lead to much more accurate and jam-proof global positioning system type data for both military and commercial users. Joanna Hinks, a senior aerospace engineer with the Air Force Research Laboratory, highlighted how integral GPS is to our daily lives and that NTS 3 is about evolving and augmenting it to maintain its gold standard.
That sounds like a significant leap forward for navigation tech. Where will this new satellite operate from?
It's bound for geosynchronous orbit, about 22,300 miles above the equator. That's significantly higher than the typical GPS satellites, which operate at 12,500 miles. This higher perch, combined with an advanced phased array antenna, allows it to directly electronically direct signals to receivers across broad regions.
So the Vulcan is designed specifically for these high altitude specialized missions.
Precisely. ULA President and CEO Tory Bruno explicitly stated that the Vulcan was purposely designed to support these missions, doing direct inject to GEO for the Space Force. He highlighted its capability to launch heavy payloads directly to high orbits without requiring the satellites to use their own limited propellant for transit, essentially saying one core is cheaper and more efficient than 3 expendable cores from other heavy launch vehicles.
That's a direct challenge to the competition. What does this mean for ULA's future launch schedule?
ULA is really ramping up. They're expanding their ground infrastructure and expect to launch 9 flights in 2025, aiming for a cadence of 2 per month by the end of the year. For 2026, they project between 20 to 25 flights, so the Vulcan is set for a busy operational future. Shifting our gaze from launches to deep space with a follow-up to one of our stories from yesterday's episode, there's a fascinating proposal on the table that could see NASA's Juno spacecraft intercepting the third interstellar object ever detected.
That's incredibly exciting, Avery. You're talking about Comet 3I Atlas, right? It was just detected on July 1st, 2025 by the Atlas system in Rio Hurtado, becoming only the third interstellar visitor we've ever observed, after Oumuamua and 2I Borisov.
Exactly. And the exciting part is the proposal from a team led by Professor Abraham Loeb of Harvard University, along with Adam Hibbard and Adam Kroll, to use our existing Juno probe. Their analysis suggests Juno could intercept 3I Atlas once it approaches Jupiter on March 16, 2026, offering us an unprecedented close look at one of the universe's most enigmatic objects.
That's a truly rare opportunity. It highlights the serendipitous nature of these celestial encounters, especially since it's practically infeasible to launch a dedicated mission from Earth to catch 3I Atlas, given how little warning we had of its arrival. The fact that it happens to pass so close to multiple planets like Mars, Jupiter, and Venus is a strange coincidence indeed.
It really is. The scientific value of such an encounter would be immense. Studying interstellar objects as they pass through our solar system offers a unique window into the conditions present in other star systems, without us needing to send a spacecraft all the way there. It's like getting a cosmic sample delivery.
And this isn't just about understanding other star systems. Professor Loeb, who became quite well known for his hypothesis that Oumuamua might have been an extraterrestrial spacecraft, has also explored the controversial possibility that 3I Atlas could be an artificial object. While they don't necessarily subscribe to it themselves, they argue that it's a hypothesis worthy of scientific analysis given its potential implications.
That definitely adds another layer of intrigue to the mission. The proposal outlines how a Jupiter Oberth maneuver involving specific thrust applications in September 2025 could shift Juno from its current orbit to intercept 3I Atlas near Jupiter on March 14, 2026. If successful, this would not only provide invaluable data, but also rejuvenate Juno's mission and extend its scientific lifespan beyond its originally intended termination.
A win-win then. Juno's suite of instruments, including its near-infrared spectrometer, magnetometer, and visible light camera, would be perfectly positioned to probe the object's composition, delivering data that could address fundamental questions about its origin and nature. even if recent Hubble images suggest its nucleus is smaller than initially thought for a technological artifact. The insights we'd gain about what lies beyond our solar system would be absolutely fascinating. From looking out into the cosmos and beyond, let's bring it back closer to home, or at least closer to the idea of future homes for humanity. NASA and Google are teaming up on an incredibly innovative project, an AI medical assistant for astronauts headed to Mars.
That's right, Anna. As space missions get longer and further from Earth, keeping crews healthy becomes a massive challenge. Think about it. Astronauts on the ISS have real-time communication with Houston, regular cargo deliveries of medicine, and can be home in a pinch. None of that will be true for a Mars mission.
Exactly. This push for Earth independent medical care is leading to some fascinating developments. This new tool is called the Crew Medical Officer Digital Assistant, or CMODA, and it's a proof of concept AI designed to help astronauts diagnose and treat symptoms when a doctor isn't available or communications with Earth are blacked out.
It's a multimodal tool, meaning it incorporates speech, text, and images, and it runs within Google Cloud's Vertex AI environment. NASA actually owns the source code and has helped fine-tune the models utilizing Google's platform, which provides access to various models.
They've put CMODA through some initial tests too, simulating scenarios like an ankle injury, flank pain, and ear pain. A trio of physicians, including an astronaut, graded its performance.
And the results were impressive. They found a high degree of diagnostic accuracy, with the flank pain evaluation and treatment plan judged 74% likely correct, ear pain at 80%, and an impressive 88% for the ankle injury.
The plan is to gradually expand its capabilities, adding more data sources like medical devices and training the model to be situationally aware of specific space medicine conditions, such as microgravity.
While it's primarily for astronauts, the potential for this technology to extend to medical applications here on Earth is huge. As Google's David Crowley mentioned, the lessons learned from this tool could have wide applicability to other areas of health, especially in remote or underserved areas. It's a perfect example of how space technology often finds its way back to benefit us on our home planet.
And that brings us to the end of another fascinating episode of Astronomy Daily. What an incredible array of advancements we've covered today.
Absolutely, Anna. From Europe ushering in a new era of weather and climate monitoring with the METOP second-generation satellite, to ULA's Vulcan rocket launching its first Space Force mission, it's clear innovation is booming.
And let's not forget the thrilling possibility of NASA's Juno spacecraft intercepting the interstellar comet 3I ATLS, offering us an unprecedented look at an object from beyond our solar system.
Plus, the groundbreaking work NASA and Google are doing with the AI medical assistant, CMODA, is paving the way for safer, healthier, long-duration missions to Mars. It really shows how space exploration pushes the boundaries of technology in all fields.
It truly does. We hope you have enjoyed diving into these stories with us as much as we have enjoyed sharing them. For more space and astronomy news, simply visit our website at astronomydaily.io. You can also find all our back episodes there, ready for your listening enjoyment.
Thank you for tuning in to Astronomy Daily. Stay curious, keep looking up, and we'll be back tomorrow with more cosmic insights.